Welcome back everyone to our statistics class notes. We're now at the top of page 95 and we're almost done with section 7.1 in which we're introducing surveys and populations and samples, and populations have parameters and samples have statistics. And then we spent some time talking about bias, whether it's measurement or sampling bias is the things I want you to be able to distinguish from. Measurement bias equals bad question, sampling bias equals bad sample. And then lastly, I want to make you understand a little bit about simple random sampling. This is the best sample to gather. So we want to draw subjects at random from the population without replacement. That means that we're not going to interview the same person twice for a survey or send the same person a second survey, etc. Okay, a random sample is one in which every member of the population is equally likely to be chosen for the sample. A true random sample is difficult to achieve, and statisticians have developed methods for producing random samples that can be used to estimate characteristics of populations. Do you think the sample that you gathered from our class surveys was a simple random sample? So I'm hoping that you would all say no at this point, because every member of the Flagler College student population was not equally likely to be chosen, since only statistics students were surveyed. Okay, so moving on to section 7.2, here we're measuring the quality of a survey. To measure the quality of a survey, we want to use accuracy and precision. Now, what does that mean, accuracy and precision? Well, we'll talk about that in just a second. Describing the important features of a sampling distribution, including the standard error, is our next major goal in this section. Okay, so when we evaluate surveys, we don't evaluate specific outcomes. What we do is we evaluate the method used for the survey. Okay, and the goal is accuracy and precision. An estimation method should be both accurate and precise. Accurate means that the method measures what it intended. It correctly estimates the population parameter. Precision or precise means if the method is repeated, the estimates are very consistent. So if method is precise, if the method is repeated, in this case, if we do another bunch of surveys, we get a whole nother sample data set, the method should be consistent, right? We should get a similar result as to what we got the first time. So this is sort of a bullseye, a target explanation of that. In this lower right here, you can see that. So pretend that the bullseye is the population parameter that we're trying to estimate. Say the population proportion of people who support the job of the current president, something like that. So if we do a survey, we would want to get really close to that true population proportion if possible, and our sample proportion should get. So high accuracy means the sample proportion that we get would be close to the true population proportion, which is represented by the bullseye. So this is highly accurate. It's also highly precise. So if we did another set of surveys, we surveyed another 2,000 people, say, and we got another proportion of that sample, it ought to be close to what we got the first time, and both of them should be close to the true population proportion. That would be the last statement when I said would be accuracy. If it was close to the previous one, that would be precision. This is an example of where I'm getting good precision here. Every time I complete another bunch of surveys and get another population, or sample proportion, trying to estimate the population proportion, all the different times I do the survey gets close, but the problem is none of them are actually close to the true population proportion, which would be high accuracy. So these are all precise, but they're not accurate. And these are examples. This one is low accuracy, low precision. This is high accuracy. They're all kind of around the bullseye, but they're not very precise because they're bouncing back and forth around the bullseye a little bit. Okay, does that make sense, I hope?